हेलो बच्चों, welcome to Sai Academy. In this video lecture, I will teach you about how to solve the problems based on trigonometrical identities. Let us solve the problems related to trigonometrical identities. So here you have to prove that question number first, sin theta cot theta plus sin theta cosec theta equals to 1 plus cos theta. So proof. LHS is given as sin theta cot theta plus sin theta cosec theta. That can be written as sin theta into cos theta by sin theta plus sin theta into 1 by sin theta. That gives cos theta plus 1. This sin theta will be cancelled out, and this will also cancel it out. So it becomes cos theta plus 1. That is equal to RHS. Hence, the problem is proved. Now, let us solve the question number. The second question. Question is, prove that 1 by 1 plus tan square theta plus 1 by 1 plus cot square theta equals to 1. So let us prove this. So LHS is given equals to 1 by 1 plus tan square theta plus 1 by 1 plus cot square theta. So that is equal to 1 by 1 plus sin square theta by cos square theta plus 1 by 1 plus cos square theta divided by sin square theta. So this gives cos square theta divided by cos square theta plus sin square theta plus sin square theta divided by sin square theta plus cos square theta. So you can see that the denominator is equal to 1 for both of the terms. So we get cos square theta plus sin square theta, which equals to 1. This is because we know that sin square theta plus cos square theta equals to 1. So this is an identity. So we proved the problem, that is LHS equal to RHS. Now the next problem, question number 2. We have to prove that cot square A minus 1 by sin square A plus 1. So let us prove this. We are given that LHS is equal to cot square A minus 1 by sin square A plus 1, that is equal to cos square A by sin square A minus 1 by sin square A plus 1. After taking LCM of these two terms, we get sin square A here, and it becomes cos square A minus 1 plus 1 here. Now take the minus common out. So we get 1 minus cos square A divided by sin square A. We will apply the identity sin square A plus cos square A is equal to 1. So we get this equal to 1 minus sin square A divided by sin square A, that is equal to 1 minus 1 gives equal to 0. Hence we prove the problem that is given cot square A minus sin 1 by sin square A plus 1 equals to 0. So we get LHS equals to RHS. Now the next problem is to second part. We have to prove that sec of A into 1 minus sin A into sec A plus tan A equals to 1. So let us prove this. So proof, we are given that LHS equals to sec A 1 minus sin A into sec A plus tan A. So we can write sec A equals to 1 by cos A into 1 minus sin A into 1 by cos A plus sin A by cos A. Therefore, we get cos A here common out. So we have 1 by cos A into cos A, that means cos square A into 1 minus sin A into 1 plus sin A, which in turns give 1 by cos square A into 1 minus sin square A, that gives cos square A divided by cos square A, that means equals to 1, which is equal to RHS. Thus we prove that LHS is equal to RHS. Now problem number 3. So in problem number 3, we have to prove that 1 by 1 plus cos A plus 1 by 1 minus cos A equals to 2 cos A square A. Now let us prove this. So proof is, now let LHS is equal to 1 by 1 plus cos A plus 1 by 1 minus cos A. That can be written as, taking the LCM, 1 minus cos square A, and numerator is 1 minus cos A plus 1 plus cos A. That means we have 2 by 1 minus cos square A, which after applying the identity, this becomes sin square A, that is equal to 2 cosec square A. बच्चों, I have applied the here 1 plus cos A into 1 minus cos A equals to 1 minus cos square A. That is, you know the identity A plus B into A minus B equals to A square minus B square. So this is identity which we apply here. So this becomes equals to RHS. Hence the problem is proved.